Hello guys, in this video I'm going to show you how to solve smallest window containing substring. So, problem statement: given a string and important, find the smallest substring in the given string which has all the characters of the given pattern. Right? So our strings is A, A, B, D, E, C, and pattern is A, B, C. What is the smallest substring? By substring, we mean a continuous set of characters, right? So for example, AAB is a substrings, right? But AA and C, for example, is not, because it's not contiguous. So the expected output here is ABDEC, which contain this pattern ABC. Here we have AB and the C at last, right? So as long as our contiguous substrings contain this pattern is valid, right? But here we just want to find the smallest substrings, right? Which is the substring that has smallest length. So probably we need to check, right, different substrings and trying to find valid substrings that contain this pattern, right? So our constraints here is the current substrings must contain this pattern, right? So wanna keep checking, right? And until we can check all the possibilities, then probably we can find a smaller substrings, right? Okay, we have substrings. So we have a given strings. We need to check different substrings that satisfies constraints. So when you have something like that, probably we can think of using sliding window, right? Why sliding window? Because sliding window help us to check different subarray, or in this case substrings, right? So for each window, gonna check whether it satisfies a constraint or not, right? And depending on that, wanna keep either shrink the window down or expand the window. Let's get into this specific case and how I wanna apply sliding window here. So let's say we have A, B, D, E, C. So let's say, for example, our current window is here. Let's say we're in the middle of the way. We're checking this window, AAB, right? Our questions is this window contain this pattern or not. So how do we know a window contain a pattern or not? One way here is to just count the frequency of each character in the pattern and in the current window, right? If they have the same set of characters with the same frequencies, then it is a uh, match. But in this case, we just need to check it contains or not, right? So it doesn't need to be it doesn't need to match all the characters, right? But as long as our window contains characters in a pattern, right? And each character has equal amount or equal or greater than or equal to the amount of character in here. Like for example, here we give ABC. Essentially, it means that we have uh, oops, A with frequency of 1, B with frequency of 1, and C with frequency of. So, for example, our current window is, let's say, A is 2, uh, D is 1, B is 1, and C is 1. This one is still a valid window. Why? Because it has all the characters in the pattern, right? It had A, right? It had B, and it has C, and the frequency is greater than or equal to the pattern. Like here for A, which has frequency 1, here we have 2, right? It means it still include at least one A character. It's still valid. And B we have 1, right? We need 1B here. C we have 1, right? Here is a valid window. So so for a given uh, window, we need to probably count the frequency of each character. And yeah, of course you can do that, but it's gonna in order to do so, we need to maintain uh, two different map, right? Two different map of characters and frequency, right? One map is of the pattern, one map is of the current window, right? So we start expanding a window and keep updating the map of the current window. But there's probably a better way here, which is you can use only one map, right? Which is the map that is built from the pattern here, right? So here is initial state, right? So as we update a window, right? Like for example, we have two operations we can do here, which is expand the window or shrink the window down, right? So for expand the window, like in the first step here, for example, I need to, let's say we start from an empty string, right? A window is of size 0, and the first step is probably to expand it to size 1, and starting from first character A, right? So for new character, that is added to our window, to a current window. Then I'm gonna check if it is in this map, in the map, pattern map, right? If it exists in this map, right? I'm gonna decrement the frequency of that character by 1. So here, because I found 1A in the current window, I will update it down to 0 here. So uh, it means we're done finding uh, we're done finding A, or put it in another way. Our current window uh, includes all the A character needed, right? So what should another thing that we can do here can help us to uh, easily check whether or not where we have included all the characters uh, uh, include all characters in a window is to use a variable, right, which is, let's say, match. Let's say initially is 0, right? So uh, when we have a character that reach 0, we can increment the match to by 1, right? So it means that let's say in this case, when we have 3 match, it is when a frequency of A is 0, frequency of B is 0, frequency of C is 0, then the time I have 3 match, right? Then it means that our current window includes all the character of the pattern here. So let's proceed from what we left off here. Okay, I have one match here, which is A, and as you can see, we have one match. Here we have 3 match in total in order to include all the characters. So it means that here the next step probably to expand our current window. Like we have 2A here. So if I expand the window here, it means A will go down to -1, right? So when A goes down to -1, I probably this match is still 1. Why is that? Because initially the frequency of A is 1, right? So when it reaches 0, it means that our current window uh, has 1A, and when it reaches -1, it means our window have 2A, right? And obviously that it still includes the A character here, right? And what we need here is only one A character, right? But even when we have two A's, um, it's still a valid window, right? So here we still consider it is one match. So now we have one match, and next step is still probably to expand the window to B. Okay, so B does it exist in this map? Yes. So I will update here by decrement it by 1. So B now is 0. It means we're done with B now. We have found enough of B for the window, right? So when it reaches 0, probably I will update the match here to 2, right? So we have 2 match, and we need a 3 match. So I can still expand the window to D here. I'm going to check the D. Is it in the pattern map or not? No, it's not. So our pattern map stays the same, and the match also stays the same. So we're not there yet. So expand the window one more step. A, B. Oh, here it should be DEC instead, right? So E, the newly added characters to our window is E. Is it in the pattern map? No. So we still need one match. So expand the window to C. Right? Is C in the map? Yes. So we update it down to 0. So now when C reaches 0, it means I will increment the number of match to 3. Right? So for all the characters in the pattern, we have uh, a valid window now, right? So it will be a valid window when the frequency of each character is 0 or below, right? So here is 3 match, which is all we need here. So it means the current window is invalid. So I will store the candidate, let's say, is AABDEC, which is a current window, right? So when we have a valid window, we probably don't want to expand it further, right? But the next step would be to ask the questions, can we find a better window than the current window? How can we do that? We can do that by shrink the window down, right? We start all the way from the first character to the end. And now another possibility is to shrink the window from the left pointer here, right? So here will be the new window, but by shrinking it down like this, I have uh, excluded one A character here. So it means I need to update the A here up to 0, right? Even though A is incremented by 1, and we have now frequency of all characters is 0, so it's still a valid window, and the number match is still 3, so it's still a valid window, right? So I will store it A, B, D, C is still a candidate, and it is obviously that this candidate is better than the previous one because the length is shorter. Obviously this one will beat the previous one. So again, we ask questions. Can we find a better window? Can we find better window? The next step is to further shrink it down. So now I've just excluded one more A from here. So now I go up to 1, and the number of match is obviously down to 2, right? So the current window is not a valid anymore, right? It's not a valid window anymore, so here will not be a candidate. The next step, when the current window is not valid, it means it's missing something, right? So we need to expand the window to include more characters. So here I expand the window by moving the right pointer rightward, but by doing so I reach the end of the, I go out of bound here. So it means we have checked all the possibilities that we can check, right? So we stop here, and the best answer that we can find is this one. Alright, so it's enough for explanations. Let's get into coding. So first thing, let's try to write down what we need to do here, right? Which is firstly to build a map of characters and frequency, the map where the key is characters and the value is frequency out of pattern, right? And we start sliding the window, right? Probably before sliding the window, I need to keep track of what? Keep track of match, which is this one, right? We keep track of match along the way. We need to keep track of current smallest container, current smallest. So when I decide to slide window, okay, this is fine. And then at the end, I will return current smallest. Right? Okay, let's first build a map out of this pattern. So let's call it pattern map, right? It's just a objects. So when I go through every characters in the pattern of pattern, and if the character that is not in the pattern map yet, then I will initialize its frequency to 0, and right after that I will increment the frequency by 1, right? Okay, so I need to keep checking on math. It's just a count variable. Keep track of number current smallest is just here we need to return a string instead. So initially it's just a empty string, and in the end I will return current smallest. So for sliding window we need 2 pointers, right? Which is, let's say, window start, right, is 0, and window end to be in a loop. Window end we start from 0, right, and window end will go all the way to string, the last index of string, which is string.length minus 1, right? No, not I, but window end. So here at the beginning of each iterations, we are assuming that we have just added the character at the window end here. So let's store it as a new character, right? Is the character at window end index, right? So as we discussed, as we added here into our current window, I will need to check if the current characters is in the pattern map or not. So if only if it in the pattern map, then I will update, right, the frequency decrement by 1. So pattern map, the new character decrement by 1, and when it reaches 0, the frequency of new character reaches 0, right? And I'm gonna increment the match by 1, right? So only when it reaches 0, we will increment the match, right? So for whatever values is that is below 0 will not update, right? Okay, what next here? So here, so when it comes here, it could be the case that our match has been updated, and it could the match is essentially for checking if the current window is a valid window or not, right? So here we ask questions if current window is valid. So we want to do that by checking. Want to check whether the value is match, and when it, let's say this guy is essentially the value match equal to number of keys that we have in this map, right? Pattern map. So number of match equal to object dot key of pattern map, right? It means that here's current window is valid window, right? So if it's a valid window, I'm gonna check it with the current smallest here, the current smallest, right? So let's say what I need to check here is to if we need the window size, right? Let's say want to check the current window size against the current smallest here. Let's say here that window size can be calculated from window end and window start. Window end minus window start plus 1, and if the window size is less than, if the window size is less than the current smallest dot length, then current smallest will be the current window, right? So how can we get the current window here? So actually we can use a method here. Not sure whether it is substring, right? Because we have the first index of the window, and we have to size the window. Then we can use substring here. The first argument will be window start, which is the first characters. The second will be the size of the window, right? Of the substrings, which is window size here. But this is gonna fail on the first match. Why? Because on the first time we get inside here, the current smallest is empty strings, right? So this this is not gonna be a match here, right? So window size will always greater than, here is 0, because smallest empty string length is 0, right? So we'll never get in here. So for the first round, we need to check if the current smallest is empty string, right? then we just reassign right away, right? But when it is not the case, then we'll check the second conditions. Okay, so as we discussed, when we have a match, we ask questions, can we find better result, right? So here, can we find better substring? How can we do that? We do that by shrink the window, current window down. Okay. We want to shrink the current window down, right? So it means we need to move the window start rightward, right? Want to do something like window start plus. But by doing this, we need to update the pattern map as well, right? So before update this one, I probably need to store the current value first, which is first character, right? It is a character at the Windows start. And then I'm gonna check whether or not this first character is in the pattern map. If it is in the pattern map, I need to increment the frequency of that character by 1. The first character by 1. Right. So by updating this one, the match could be updated as well. So we want to update the match here when the pattern map of the first character is greater than 0. So if after updating here and the value is greater than 0, then number of match will be decremented by 1. So here, okay, here's the first character. And the first character here, if it's in the pattern map, I will update the frequency of this by 1. And when it greater than 0, it means that we need to update the match here by decrement by OK. So after that, I will increment the Windows start by 1. Right. So actually, in this operation, we want to keep doing, right? As long as this still match, right? Which is as long as the current window is still a valid window, we want to keep doing this, right? So here, Probably we need to make it a while loop, right? So as long as the current window is still a valid window, we want to consider update this current smallest and then shrink the window down, right? Or another condition that I can think of here is the window size, right? Probably we don't want to actually this one if I guess. Let's try to see if it works or not. Okay, now run the test. We have two failing tests here. Let's see. This one instead. I failed here. Let's debug it. See what is wrong here. All right, let's get into it. So do we have? Okay, we have gradient here. Window. Okay. Okay, the new character will be a. Is it? Yes, in the other map. Okay, it reaches 0, so I need to increment the match here. So we'll get in here. No. Next character, another A. Okay. We still have one match. Now it's B. Okay, we have two match now. Right, okay, we have two match. Now we have three match, I guess. Oh no. It's D, which is not a match. But now it's E. Alright. The last character. Okay. So now we have three match. Okay, number of match will be equal to number of keys here. So we get inside. What? Oh, here should be length instead. My mistake. One more try. Okay, it works. So that is it for this problem. Thanks for watching. See you in the next video.